let's look at number 6 on 7.1. It says use the sample data and confidence level given below to complete parts A through D. A Research Institute poll asked respondents if they felt vulnerable to identity theft. In the poll, N equals 961 and X equals 532 who said yes. Use a 99% confidence level. And then you can use the table for the z-scores, or we're going to use StatCrunch or our calculator. So find the best point estimate of the population proportion P. So remember, best point estimate is your proportion, which is P hat. P hat is X divided by N. So you're going to do 532 divided by 961. Which is going to give us 0.554 when you round to 3 decimal places. Okay, now the next part involves finding your error, which if you have looked at the handout for the Chapter 7 formulas, your error formula is right here. You do z alpha divided by 2 times the square root of p hat times q hat divided by n. So before you can do this, we need to find our z alpha, which you can use your calculator or StatCrunch. This is the steps for the calculator. This is the steps for the StatCrunch. We just did this in an earlier example, so let's go back to the StatCrunch. And remember that the z alpha divided by 2 has to do with your confidence level. So if we have a 99% confidence level, that means we got 0.99 here centered in the middle, which means the two tails are going to be split with 0.01. That's going to be our alpha. So our alpha divided by 2 is going to be 0.005. So that's the area in your two tails. So we need this z-score right here, the z alpha divided by 2. So in StatCrunch, you're going to do stat, calc, normal, leave it at 0 and 1, and you're going to change that to 0.005, and we want to change that to greater than, and compute. So our z alpha is going to be 2.58. Okay, so using that, our z alpha divided by 2 is 2.58. We're going to use our formula to find error is z alpha divided by 2 times the square root of p hat times q hat over n. So we've got 2.58 times the square root. Our p hat was 0.554. Q hat, remember, is the complement of p hat, so you need to do 1 minus 0.554. That's going to be 0.446. And then you divide that by n, which is 961 in this problem. So you're going to plug that in your calculator to get your error. Let me see if I can move that over so we can see. Can't see it all, but so I've got to 0.58 times, and then I'm going to do the square root, and in parentheses do 0.554 times 0.446, close that parentheses, and divide by 961. I want to make sure that all of that is under the parentheses. Under the square root. And so I get 0.0413 or 14. And I'm not sure how many it told me to round to. It told me to round to 3, so 0.041. Now from there, you can construct the confidence interval. The confidence interval is p hat plus or minus your error. So p hat plus or minus your error. When you subtract, that'll give you your lower bound. When you add, that'll give you your upper bound. So you're going to have 0.554 minus 0.041, and that'll be your lower bound. And then you'll have 0.554 plus 0.041 will be your upper bound. So here we're going to have, subtract, not add. That'll be our upper bound. And then when you subtract, so P is going to be between 0.513 and 0.595.